Next, we come to another part which many junior form students find hard, which is called factorization. But before we talk about the first technique called taking out common factors, so let's take a look on what's actually about factors first. So factorization, you can link up with the word called factor. And then for example, can you list out the factors of 15? And you know is 1, 15, so they are factors. You can also have 3 and 5. So these are factors of 15. For example, 12, can you list out some factors of 12? Yes, you have 1 and 12, 2 and 6, you have 3 and 4, and that's all. When you see I list out the factors, you see I'm talking about products. For example, 12 I'm thinking is 1 times 12. 12 is talking about 3 times 4. 12 we are talking about 2 times 6. So this is a way how I can list out the factors in a very systematical way. After writing down 12 into different ways, like 1 and 12, 3 times 4, 2 times 6, then we can also think of how we can simplify a fraction, 12 over 15. You know it well when you were in primary school, like after simplification is 4 over 5. But what the idea behind it is actually about factors. Because 12 you can write as this is called 3 times 4, while 15 it can be written as 3 times 5. You see I write down 12 and 15 into products respectively. So afterward you can see that because both of them they have the factors 3, which can be cancelled up and down, so it comes to the result of 4 over 5 finally. So by this idea we want to extend it into polynomial. So that is, for each number I want to write it down as products, so which is called the idea of factorization. And the next, when you have same factor, it can be cancelled to each other. So let's start. The first technique of factorization will be called taking out common factor, which is everyone knows that when you were in Form 1, then we have called expand. For example, if you want to expand a times x plus y, which is in product at first, so a will be multiplied to x and y respectively, giving you ax plus ay. So now we want to do a reverse, which is we want to write ax plus ay because they share the same common factor called a. Next, it will be taken out, and so that we write as a product. And this process is called factorization, and the verb we use is called factorize. So if you understand this idea quite well, then we may try to take a look in number 1 and number 2 to see how it works. For example, now in 1b, so each of them you see they share a a. So that's why a will be taken out. If a is used up for a squared, I still have a. That means a times a. Minus sign in between follow. After we take out the a, we still have a 3. So that's why it's a times a minus 3 in this factorization. And you can link up the answer to the last one. Sometimes we have negative like 1d. We have negative 3, which is the same. And so after you take out the negative 3, you still have an a. That means minus 3a is written in outside brackets and inside brackets. Minus sign follow, but because negative sign is used up, so you have plus. Negative 3 is taken away, so that's why we have b. And that's how you get the answer for 1d. Coming up next, let's take a look in, for example, number 7. Sometimes the common factor may be big. For example, you see a cubed and a squared, so that's why we can take out a squared. But I forget to look at 5 and 10, which they share the same common factor of 5. Okay, write down the expression inside brackets. 5a squared is taken away from 5a cubed, so that's why we still have an a inside. Negative sign is followed. 5a squared is taken from the blue one, so we still have a 2 remained. So this is the basic principle of factorization by taking out common factor. Another one which you may find very big common factor will be like number 10. So normally I will start from numbers. So you have 4 and 6, common factor is a 2. so with a bracket. The bracket should be written in this way, it will be better. And next, x and x squared, so you take out x, y, no y, so it's not a common factor, ez, so there's a common factor. So after taking out the 2x ez, so now let's see what is it. 4xy ez, taking away the 2, so you have a 2. Taking away the x, use up, y is left, taking away the ez, minus 6xy ez, 2 is taken away, so you have a 3. X is taken away, so that's why you have an x, and that is. Next, we have two very hard questions in number 15, because sometimes the common factor is even bigger. For example, like number 15, so you see n minus n and n minus n, they are common factors in the first and the second expression. So that's why n minus n is taken out as a very big common factor. And what's left behind? And you still have n minus n. By chance, because they are the same, so don't forget to put them together as bracket square. And that is for number 15. Number 16 is even harder because part of it is kind of factorized, but the second and the third terms, they are scattered, they are separated. So that's why normally the technique or the little trick we may use in number 16 will be the first one, which is in brackets form, I will keep it. While for the second one, I will try to find a way to group them, because they are in two terms now. So this is a little trick in question like number 16. So let's go on. A times 2y plus 1. And now, because minus 2, not minus 2b, what should we say? Minus b and minus b, they are common factor for the last two terms. So I take out minus b. After taking out minus b, so what's left in this term? Yes, 2y. Minus b is used up, so what is it? Yes, plus 1. So that's why you successfully make a common factor in these two terms, which 2y plus 1 can be taken out, and a minus b left behind. That is for number 16. So after you understand this one, remember to put a star on it, or even you put it in a notebook for your revision.